Focus on the particular section of the code. That is where the actual logic is. This line is just declaring the method is a palindrome. For those that are not familiar with Java, I'm declaring the method is a palindrome, which takes an integer parameter named number and returns a boolean. On the next line, I was storing the parameter that was passed into the method into another variable called number passed. This is because through this algorithm, I will manipulate the value of this number. So that means the value of this number will change as the algorithm executes. And for at the end of the code, I will need this particular number to arrive at my answer. So I was basically just saving it temporarily in this number passed while I manipulate the actual value stored in number. The next line, I declared my integer number reverse to be equals to 0. What I was trying to do basically in this algorithm is to reverse the number that was passed into the parameter and compare it at the end to arrive at my answer. Basically, if the reverse of the number that was passed into the method is equal to the actual number, then it's a palindrome. If they are different, then it's not a palindrome. That's the basic logic behind the palindrome. Take for an example, sorry, we have integer 1 to 1. 1 to 1 is a palindrome because if you read from left to right, it reads 1 to 1, and if you read from right to left, it reads 1 to 1 as well. That's the basic logic behind the palindrome. Yeah, so let's say the number was passed as a string. Now we could have just reversed the string and compare it, but then this is an integer and we're given a constraint not to convert the number into a string. That would have made everything easier. So because of this constraint, we need to be more logical about the algorithm. That is why sorry, that is why I have this while loop here. What I'm trying to do basically in this while loop is to obtain the reverse of the number, and the way I'm tackling it is I'm extracting the last digit in the number, that is the rightmost digit in the number, and I'm adding it on the fly. So take for an example 1 to 1. Let's want to process number 1 to 1 now. This while loop will check if my number is not equals to 0. Yeah, this will pass as true because number is 1 to 1 not equals to 0. This particular line will check the last digit. Not check, it to extract the last digit, I mean. So we have number mod 10. Number mod 10 will obtain the remainder after the division. For example, we are considering 1 to 1. 1 to 1 mod 10 will give us 1. So 1 is the rightmost digit. So it will be stored in this last digit. Number reverse is now equals to number reverse times 10 plus digit. What I'm doing on this line is basically add the last digit to this number reversed, but I'm doing an extra work. So I'm saying the number stored in the number reverse should be multiplied by 10 before I store the last digit. This is something logical, right? Because let's say for an example, initially 0 is stored in this number reverse, right? 0 times 10 will give me 0, then plus that is last digit. That means my number reversed will be 1 in this case. I'll explain how it matters in the next loop iteration. Let's continue for now. Number is now equals to number divided by 10. Number divided by 10 is to obtain the actual quotient of the division, that is the actual value of the division. For our example, 1 to 1 will give us 12. So number 12 will be assigned to variable number now. Then we go through the loop again. 12 is not equals to 0, so the loop passes. Then we have last digit. Our last digit in this case will be 12 mod 10. We'll obtain 2, right? Because 12 divided by 10 is 1, remember 2. Number reverse is now equals to number reverse times 10. Number reverse times 10 in this case will be 1 times 10. Remember in the previous loop, number reverse was 0, so at the end of the loop it was 1 that was assigned to number reverse. But in this case, something is stored in number reverse right now, which is 1. 1 times 10 will give us 10, then plus our last digit, that will be 10 plus 2, so we have 12. So what this 10 is doing is adding extra 0 to what we have in the number reversed. And this is because after we've stored 1, that is in tens, the next number, oh, that is in units, right? That's just 1. So the next number that we need to add to 1 must be in tens, that is 12, right? In this case 12. So that was the main reason I was adding this extra 0. This multiplication by 10 was just giving me extra 0 that I need to do my addition. Let's say this multiplied by 10 was not there, it would be 1 plus 2, which will give me 3, and 3 is not what I want. Do you understand? I want 12, so I was multiplying by 10 to give me extra 0, so I can add my digit 2. So number reversed will now be equals to 12 in this case. Number will now be 12 divided by 10, which is 1. That is the actual quotient when we divide by 10. 1. So go through the loop again. Last digit in this case will be 1, because 1 divided by 10 will give me more. 1 more 10 will give me 1. Then my number reverse will now be equals to number reverse times 10. What I store in number reverse, and our number reverse right now, it is 12. So 12 multiplied by 10 will give us 120. Then plus our last digit 1. That's number reverse is now equals to 121. Number will now be equals to number divided by 10, which in this case is 0, and the loop will terminate. At the end of the day, we are returning if our number reverse is equals to number passed. Remember, I saved the number that was passed into this method into this number pass, that is initially number pass will be initialized to 121, and also my number reverse at the end of this loop was 121. So I'm checking if 121 is equals to 21, and this will return true. So that's the basic explanation.